Alright guys, I'm going to do 3C for you. So make sure you've actually already tried this before you watch this video. So it says that the engineer in charge of this process expects a yield. So they want a yield of 81.5%. If you have 1.4 times 10 to the 5th moles of calcium phosphate, how many moles of phosphorus will you produce? So we need to figure out, first of all, what is this actually asking for? So the moles of phosphorus produced, because phosphorus is a product and they're saying produced, we're actually talking about what actual yield is. So they want to know what actually is yielded from this reaction. If there is a 81.5% yield. Now 81.5% as a number is equal to 0.815. Now, as a problem solver, what I would want you to do here is think about, what do I have that relates this kind of information together to solve for the moles of phosphorus? And the one you know is going to be actual yield divided by theoretical yield equals, and it's 100 times that or just this. So I'm just going to set it equal to the number 815. All right, so we want to know what the actual yield is. Let's figure out what the theoretical yield is. Every single time we are going to do that via stoichiometry. So the one thing they do give us is that you're starting with 1.4 times 10 to the third moles of calcium phosphate. And I have to get to my theoretical yield of phosphorus. And they want the answer in moles, so we can stay in moles and not bother with mass, which is nice. So I want to go to moles of phosphorus. All right, so we're going to look at our original problem and see what the molar ratio is between calcium phosphate and phosphorus, because that's where we're going, from moles of calcium phosphate to moles of phosphorus. So we see that there is 1 mole of calcium phosphate per 2 moles of phosphorus. So 1 mole of Ca3PO42 over the 2 moles of phosphorus on top. Okay, remember, you're always going to put this unit in the bottom, and I did, so it crosses up. And then you ask yourself, am I where I need to go? I needed to find the theoretical yield of phosphorus. And if you're talking about the same thing, so theoretical yield of phosphorus divided by and the actual yield of phosphorus, you can use moles, because that is just the amount of a substance. The times where you need to actually convert to mass are when you're comparing different parts of the equation. Because if we want to know the actual yield and theoretical yield, we need to know grams, because we would be talking about more than one product or more than one reactant. But when we're looking at just one substance, this ratio of moles of phosphorus in the actual yield and moles of phosphorus in the theoretical yield is fine. You could have also gone to grams, and that would have given you the same answer, just take another step. So I'm going to take 1.4 times 10 to the third times 2. I get 2.8 times 10 to the third, but I will type it out for you so you can see that. I think sometimes kids struggle with scientific notation on a calculator, so follow this with me. If I wanted to type this number in, I would put it in parentheses first of all, and then I would type 1.4, and then you hit the second function, so the blue button, and then the comma, the one right above the 7, because that EE is what I need. And it's actually going to spit out 1E for me. What that 1E tells me is that this is 1.4 times 10 to the exponent of, so this is where I type my exponent, it is 3, right parenthesis. So this is the same as this. And then I'm going to take that times 2. You can see that I get 2,800, so 2.8 times 10. Oh, how many sig figs did I have? Yep. 10 to the third moles of phosphorus. And again, this is my theoretical yield. Theoretical is what comes out of doing stoichiometry. Actual is you did it, and this is what actually came out of it. They want to know the actual yield. I now have the theoretical, and I have this. So I can plug in. I'm just going to write AY for my actual yield. I'm solving for, or maybe I'll just write A so you guys don't get confused with two variables there. And my theoretical yield comes out to be 2.8 times 10 to the third. Whoops, moles of phosphorus. It's equal to 0.815. To get A by itself, you take 0.815 times that 2.8 times 10 to the third. I get my actual yield, and it's in moles because this is in moles, equal to 2.3 times 10 to the third moles of phosphorus. Oh, so again, I just took this times this to get my actual yield by itself, to get 2.3 times 10 to the third moles of phosphorus. So again, that was 3C. All right, I'm going to stop this and do the next one as a different segment.